Today's video is on integration using residues. In today's video, we are going to solve the problem using residue theorem. So, in this video, we are going to evaluate integral e power z by z square plus pi square whole square into dz, where c is mod z is equal to 4. See here, it is clearly given as integral f of z into dz. Here, f of z value is this one. That is, f of z is equal to, this is e power z by z square plus pi square whole square. And now, in order to find the residues, you know what to do. So, we have to first of all find the poles. So, for finding the poles, we have to equate the denominator to 0. That is z square plus pi square whole square. We have to equate it to 0. So, this can be written as z plus pi I into, this is z minus pi I whole square. So here a plus b into a minus b, which is equal to a square minus b square, that is pi I whole square. We know that I square is minus 1 and minus of minus plus 1. So this will be plus pi square. So this one, that is z plus pi I whole square into z minus pi I whole square is equal to 0. Now if I equate z plus pi I whole square to 0, and next one z minus pi I whole square to 0, here z value is equal to minus pi I. So which is a pole of order 2, which is a pole of order 2, and here z value is equal to plus pi I, which is again a pole of order 2. So we got the two poles. The first one is z is equal to minus pi I, and the next pole here is z is equal to plus pi I. After getting the two poles, we have to check whether they are inside the given contour or outside the given contour. First one, here it is given as mod z is equal to 4. So here this is mod z is equal to 4. Clearly, what is mod z is equal to 4? It is a circle. So this is a circle with center 0 and radius 4. And now see, let me draw here. This is x-axis. This is x-axis and y-axis. This is 0. This is 1. This is 2. This is 3. And this is 4. And this is minus 1, minus 2, minus 3. And this value is minus 4. And here this is I. This is 2i. This value is 3i, and this value is plus 4i. And here down, this is minus I, minus 2i, minus 3i, and this value is minus 4i. Clearly, so this is a center. Here the center value is 0 and radius is equal to 4. So we have to draw like this. So this is the given circle. So in this given circle, so this is plus pi I and minus pi I. So here plus pi I is here. Pi I means pi value is minus 3.14. So minus 3.14. So here is this value and here is this value. So both are inside the circle. So if they are inside the circle, as pi value is this value is minus 3.14i. So minus 3.14i is this one, and plus 3.14i is this one. Both the poles are within the circle, and therefore we have to find the residues for the corresponding poles. For finding the residues, first of all we have to find the residue of f of z at point z is equal to z naught is, as it is of order 2, this value will be 1 by m minus 1 factorial into limit z tends to z naught. Clearly, this is d by dz power m minus 1 into this value is z minus z naught power over m into f of z. So this is the formula. So in this formula, we are going to keep what is the order value. Order is equal to 2. See here, order is equal to 2, and first of all z naught value I am keeping as minus pi I. So for minus pi I am substituting, and therefore the residue value at minus pi I will be residue of f of z At point z is equal to minus pi I is equal to 1 by order value is equal to 2. This is 2 minus 1 factorial into limit z tends to minus pi I. This is d by dz power of m minus 1. So this is 2 minus 1 into minus of minus plus pi I whole square into f of z. What is our f of z value? So f of z can be written here as f of z can be written as this is e power z by this is z plus pi I whole square into z minus pi I whole square. See here, this is a plus b into a minus b is nothing but a square minus b square whole square. So this can be written as e power z by, so this value is e power z by z plus pi I whole square into this value is z minus pi I whole square. So if I cancel these two, then see, this is 2 minus 1 factorial is 1. I'm leaving. That is limit z tends to minus pi I. We have to make one time derivative for e power 2z by this is z minus pi I whole square. As this is of the form u by v rule. So this is of the form u by v. So this is u and this is v. So we have to make v square v u dash minus u v dash. And therefore, if I make a derivative, then see what happens here. This will be clearly, this will be limit z tends to minus pi I. So v square. So this is z minus pi I power 4. And I am leaving z minus pi I whole square. So you have to make a derivative. E power z is again e power z. And next I am leaving e power z like this, and this is 2 times of z minus pi I. This is the derivative, and now if I take z minus pi I common, this value is limit z tends to minus pi I. So if I bring z minus pi I common, this will be z minus pi I into e power z minus 2 into e power z, clear, by here down this is z minus pi I power 4. So now I can cancel for one time, so this will be cube. And see, if I substitute pi I here, this will be minus pi I into minus pi I into e power minus pi I. In place of z I am keeping minus pi I minus 2 into e power minus pi I by z, that is minus pi I minus pi I whole cube. So this is whole cube. So this value will be minus 2 pi I into. So this can be written as cos pi minus I sin pi. Clear? Minus this value is also 2 times of this is cos pi minus this value is I sin pi by this is minus 2 pi I whole cube. So cos pi value I am writing, cos pi value is minus 1, cos pi value is equal to minus 1, and sin pi value is equal to 0. So if I substitute, then this will be, the value will be minus 2 pi I times of this is minus 1, that is 0, and this is 2 times of minus 1 by this is 2 cube value is 8 minus this is pi cube and this is I cube. Clear? So this is minus of minus plus 2 pi I. So this is plus 2 pi I and this is plus 2 by here I square value is minus. I square value is equal to minus 1. Therefore 8 pi cube into I here. So again if I multiply with I, so in the numerator as well as in the denominator, and see here I square value is equal to minus 1. This is minus 2 pi, and if I multiply this is plus 2I by I square value is minus 8 pi cube. And see if I take 2 common, minus 2 common, this will be pi minus I. See here minus 2 pi and plus 2I, here 8 pi cube. So if I cancel in 4 times, minus also got cancelled. So this will be pi minus I by 4 sorry, pi minus I by 4 pi cube. So even if I cancel this one, minus minus, then pi minus I by 4 I cube. This is the residue value of f of z at point z is equal to minus pi I. And therefore, the residue value at z is equal to minus pi I value is equal to pi minus I by 4 pi I. And the next is the residue value we have to find at z is equal to plus pi I. For finding the residue value at plus pi I, see here, the formula here is residue of, see, residue of f of z at point z is equal to z naught is nothing but 1 by m minus 1 factorial into limit z tends to z naught. Here d by dz power, this is m minus 1 into this is z minus z naught power m into f of z. Clearly, in this formula, if I substitute m value, the order value, here the order is equal to 2. Order value as 2 and z naught value is plus pi I now. And therefore, if I go with this and see, if I substitute all the values, then this will be residue of f of z. Residue of f of z at point z is equal to plus pi I is nothing but, in place of m I am writing 2, and next in place of z naught I am writing this is plus pi I, this is d by dz power, this is m minus 1, and this is z minus pi I power m square into f of z. So f of z is this one, that is e power z by, so this is e power z by, this can be written as z plus pi I whole square into z minus pi I whole square. Clear? Z minus pi I whole square and z minus pi I whole square got cancelled. And see here, this is 2 minus 1 factorial is again 1. This will be limit z tends to pi I d by dz times of. So this is e power z by, this is z plus pi I whole square. Clear? So this is of the form u by v rule. So this is of the form u divided by v. So the derivative here is v square v u dash minus u v dash. So I am making a derivative for this. So this is u and this is v, and clearly this will be limit z tends to pi I. So this will be v square, that is z plus pi I power 4, and again v, that is z plus pi I square into, I have to make a derivative for u. E power z is again e power z, and again I am leaving u, e power z I am leaving. So for this, 2 times of z plus pi I. Clear? So if I take z plus pi I common and cancel, so this is limit z tends to pi I. So if I take z plus pi I common, so this will be z plus pi I into e power z minus 2 into e power z by z plus pi I power, this value is 4. So if I cancel for one time, this is cube. So if I substitute z value as pi I, so this will be pi I plus pi I into e power, this value is pi I minus e times of pi I by z value, this is pi I plus pi I whole cube. So this value is 2 pi I. So e power cos pi is, pi I is nothing but cos pi plus I sin pi minus 2 times of this is cos pi plus this is I sin pi by this is 2 pi I whole cube. See here again, cos pi value is equal to, as you know that cos pi value is equal to minus pi 1 and sin pi value is equal to 0. So if I substitute, then see here, this will be 2 pi I into 0, sorry, this is minus 1 plus 0, and next one, this is minus 2 times of minus 1 plus 0 by this value is 2 pi I whole cube. So this is minus 1. This is minus 2 pi I plus 2 by, down 2 cube is 8. This is pi cube and this is I cube. So here this is minus 2 pi I plus 2 by, here this is 8 pi cube and I square value is minus 1, so this is minus. So if I take minus common and cancel, in this if I take minus common and cancel, see what happens. So this will be, so if I take minus 2 common, this will be pi I minus 1 by, down this is minus 8 pi cube into I. So I can cancel this one and 4 also. And later if I multiply with I in the numerator as well as denominator, and see, this will be I square. So the value here will be minus pi, this is minus I, by down this is minus I square, this is minus 1, and this is 4 pi cube. So if I take minus common, this will be pi plus I by, down this is 4 pi cube. So if I cancel this one, therefore residue of, this is residue of f of z at z is equal to plus pi I value is equal to, this is pi plus I by 4 pi cube. So this is the residue value at z is equal to plus pi I, the residue value is this one. Therefore, according to our residue theorem, so what is our residue theorem? By residue theorem, according to our residue theorem, so we have integral f of x dx value is nothing but, f of x dx value is nothing but, this is 2 pi I into sum of the residues at interior poles, sum of the residues at interior poles. So here our f of z dz value here is, so integral f of z dz value is equal to 2 pi I times of sum of the residues. Here our residue value is this one for minus pi by 2. See here, for minus pi I, the value here is pi minus I by 4 pi cube. And next for plus pi I, the value here is plus pi plus I by 4 pi cube. Now see, this will be 2 pi I times of, if I take 4 pi cube common, this will be pi minus I plus, so this is pi minus I and this is pi plus I. Now I can cancel these two, and this will be 2 pi I times of, this is 2 pi by 4 pi cube, and this is 2 2's are 4, and this is 2 pi's. If I cancel, this will be I by pi. So here the value here is I by pi is the value for the integral. So what is f of z here? So f of z is the question, that is e power z by. So this value is e power z by z square plus pi square whole square dz. So for e power z by z square plus pi square whole square value, the for dz value is nothing but I by pi. So this is the final answer, and let me explain you for one. So this is the question given. See here, first we have to solve the problem using the residue theorem. So we have to evaluate this one. So I am splitting this as z plus pi I square into z minus pi I square. So after equating the denominator to 0, so z is equal to minus pi I and z is equal to plus pi I are the poles of order 2. So clearly mod z is equal to 4 is given. So this is a circle with center 0 and radius 4. So pi is nothing but 3.14. So minus 3.14 and plus 3.14 both are inside the circle. So we have to find the residues for the corresponding poles. Here m is equal to 2 and z naught is equal to minus pi I. And after substituting and after cancelling z plus pi I square, z plus pi I square, and substituting and making a derivative and substituting z is equal to minus pi I, here is the residue value for z is equal to minus pi I. And the next pole here is z is equal to plus pi I. For z is equal to plus pi I, here m value is equal to 2 and z naught value is equal to pi I. And after cancelling z minus pi I square on both sides and making a derivative for one time using UV rule and substituting z value as pi I, and after solving, see here, after solving we got the residue value as pi plus I by 4 pi cube. And therefore, according to our residue theorem, we have integral f of z dz is equal to 2 pi I times of the sum of the residues at interior poles. Therefore, after adding up these two residues, and we got the final answer as I by pi. This is how we have to solve. Thank you so much for watching. This is the most important question. Please definitely practice for one more time and pass it on to your friends and subscribe to this channel for more videos. Thank you so much.